Alright, so your quizzes are in the grade book right now. If you haven't taken them yet, let's get those done ASAP, preferably by Friday, since we then take an extended break on Friday. So we are going to start chapter 5 today. We will work through chapter 5 this week. We'll pause for the cause after Friday's class. We'll pick it up again after break, and then we will finish sections 5.1 and 5.2 right before the final. Okay?
Is there going to be a test on Friday?
This Friday?
Yeah.
No. Okay? But there will be one coming back after you get back. So we get back on that Tuesday the 2nd, and then there will be one the 9th, because Mrs. Hill and I are gone. We were going to have it be on Thursday of that week, but then I said, no, we're both gone on that Tuesday. Let's have it that Tuesday. So, and just as an FYI too, your final is going to be on day 1, period 2. Everybody, Hill and Linsmeyer together in 3:15. So that will be that. Okay. In terms of this week, last week we said that it was thinking week, because you had to think about reference angles, trig angles, navigation angles, bearing angles, all that fun stuff. Okay? If last week was thinking week, this week is logic week. Okay? Alright? So there will be some thinking, there will be some theory, there will be some proof towards the end. Towards the end of this week, we'll get into the proof part of trigonometry. Okay? So we're going to explore the properties that lead us often with no immediate concern for the real-world relevance at all. Okay? All right? Meaning, we're going to take stuff that looks crazy today, and in the end, it's going to be 1. Or it's going to be something else. Okay? But we have to get there. Okay? Now, one of the things you will hear me say throughout the course of this week, and some of you have heard me say this many, many times, there is more than one way to get to Mosinee. Okay? Alright? Sometimes there's a fast way. Jumping on 39 gets you to Mosinee real quick. Okay? Sometimes there's the scenic way. You go out to Marathon and down 107 and then in on 153. Okay? Sometimes there's the why are you going that way. If I wanted to go up to Merrill to 64 and then over to Medford and then down 13 and then back in on 153. Okay? I still end up there. Okay? I still get there. We're all going to get to the same spot. It's just some of us might take a different route. Okay? And that's that whole theory and proof thing. Okay? Now, one thing that I will tell you is that it will be very beneficial for you all week, this one, to have out your unit circle sheet. Okay? To have that out sitting next to your notes while you're taking notes, because I'm not so much concerned about the actual unit circle part of your unit circle sheet as much as I am concerned with the 23 formulas that are above your unit circle. Because we're going to use those on a regular basis. Okay? So have those out at the same time too. Alright, here we go. So, the first thing that we have to remember is we need to remember our identities. Okay? Remember our trig identities. Cosine is cosine, and will always be cosine. Okay? Sine is sine. Okay, those are the easy ones. Okay? Secant is 1 over cosine. Tangent is sine over cosine. Cosecant is 1 over sine. Cotangent is cosine over sine. Okay? We got to remember those. Those are not on your unit circle sheet. Okay? So you might want to write those down, jot those down somewhere along the lines. The big one here, the hammer, if you will, is on your sheet. It's number 7. Okay? And that one will come into play in all 3 forms. As you can see here on your unit circle sheet, there are 3 different forms to it. Okay? There's the hammer, cosine squared plus sine squared equals 1. There's cosine squared equals 1 minus sine squared. And there's sine squared equals 1 minus cosine squared. Okay? All there on there. Okay? All 3 of those are part of your hammer. Okay? If I were to manipulate the hammer, I would also get out numbers 10 and 11. Formulas 10 and 11. Cosecant squared is equal to 1 plus cotangent squared is number 10. And number 11 is secant squared equals tangent squared plus 1. Okay? Those will also come into play later on. Okay? So, remember those things. All right? Let's do this. Okay? So, we are going to be today simplifying expressions. Later on this week, we will be solving equations. Right? What's the difference between an expression and an equation? The equal sign. Yep. Okay, the equal sign. Okay? Without an equal sign, all you can do is simplify. Okay? So if I'm looking at my sheet here, I would say that the secant of negative x, using number 4, would be equal to the secant of positive x. Okay, that's property number 4. Then I would say that the cosine of negative x, using property number 1, is equal to the cosine of x. Those two are still being multiplied together. Okay. Secant is 1 over cosine of x times the cosine of x. So if I multiply fractions, remember, I think of this as over 1, and I multiply across. So that gives me cosine of x over cosine of x, which can be reduced to be 1. So anytime I take the secant of a negative angle times the cosine of a negative angle, I get 1. Okay? Which makes sense because secant and cosine are opposites, inverses, if you will. Okay? Reciprocals. Okay? Number 2. Secant squared minus tangent squared. Well, if I utilize formula number 11, or property number 11, and I could say that secant squared is tangent squared of x plus 1, then minus tangent squared of x. That would leave me just with 1. Now, what if I forgot that formulas or properties 10 and 11 exist? Well, secant squared is 1 over cosine squared minus tangent squared is sine squared over cosine squared. That's a fraction that I can combine because it's got common denominators. So that gives me 1 minus sine squared over cosine squared. 1 minus sine squared, using the hammer, is going to be cosine squared over cosine squared, which is 1. Okay. What I would like you to try now is I would like you to try, oops, colorified them, try those two. Cosine times tangent, secant times cotangent. So tangent here is sine of x over cosine of x, and that's going to be multiplied by cosine of x. So I'm left with there just the sine of x. Agree? Secant is 1 over cosine of x. Cotangent, excuse me, is cosine of x over sine of x. Multiply those together and I get 1 over the sine of x, which is the cosecant of x. Before you even ask the question, yes, you will get it marked wrong if you just leave it as 1 over the sine of x. Okay? It's like, how can I say this? It's like going to Milwaukee and stopping at the Cabela's. You know where the Cabela's is on 41, just north of Milwaukee? You know, it's right in that northern suburb part of Milwaukee, but it's not Milwaukee. Okay? So you're there, you're just not all the way there. Okay? All right? Oh yeah, I like those. Try those. Yeah. So, cosecant is 1 over sine. Minus sine of theta times the sine of theta. If I distribute that in, sine times 1 over sine is 1 minus sine times sine is sine squared of theta, and 1 minus the sine squared of theta is cosine squared of theta. Questions on that one? One minus cosine squared of theta is, of x now, is sine squared of x times cosecant is 1 over sine. So that becomes sine squared of x over sine of x, which is simply just the sine of x. Questions on that one? Next two. Try those. So cosecant is 1 over the sine. Secant is 1 over the cosine. Right? Dividing fractions, flip the bottom one, flip the second one, and multiply. So this becomes 1 over the sine of theta. Oops, put my theta, that was an ugly, weird looking theta. Sine of theta times cosine of theta over 1, which is cosine of theta over sine of theta. And that, ladies and gentlemen, is cotangent. Yes? Okay. Tangent squared plus 1 is what? Secant squared. Times the cosine squared of u. So then this becomes 1 over cosine squared cosine squared divided by cosine squared is just 1. Okay. Anybody do it a different way on that one? Okay. I won't show you a different method then. Oh man, just when it got nice, then I go and drop an F word on ya. Oh man, factoring. Up. Okay, what am I going to factor out? What can I factor out? Nope. Because the x is attached to all of the trig functions. So I got to look for a trig function that I can factor out. Sine of x. Okay. If I factor out a sine of x, remember when I'm greatest common factoring, if I factor out a sine of x, then I'm going to divide that term, the first term, by sine of x, and divide the second term by sine of x. So that leaves me with what? Sine of x divided by sine of x. 1. Most common mistake in this kind of factoring is forgetting that a 1 goes there. Hold that place. Minus what? Cosine squared of x. Okay. Quick check, redistribute it in. Sine of x times 1 is sine of x. Sine of x times cosine squared of x is sine x cosine squared x. Okay, so it works on the redistributing. 1 minus cosine squared is equal to what? Sine squared of x. That's going to be multiplied still by the sine of x. Sine of x times sine squared of x is sine cubed of x. Yep. Okay. You try those two. out of the top, I can factor out a cosine squared of theta. That leaves me with 1 plus tangent squared of theta. 1 plus tangent squared of theta is the same as secant squared of theta. Secant squared of theta is 1 over cosine squared of theta times the cosine squared of theta. Those cosine squareds cancel each other out, so I'm left with 1. Okay? So that whole big long expression, all it is 1. No matter what your angle is, it's going to be 1. Okay? Last one here. I can factor out a sine of x. That leaves me with the sine squared of x plus cosine squared of x. Sine squared plus cosine squared. That's 1. That's the hammer. 1 times the sine of x is just sine of x. Okay. Last parting words of wisdom. Okay? You will make a mistake. Okay? You might turn down the wrong street. Okay? It's going to take you somewhere. Maybe you get back to where you're going. Maybe you don't. Okay? If you went and saw Star Wars this weekend, okay? Master Yoda, my favorite line in the movie, Master Yoda, failure, the greatest teacher is. Okay? Alright?